Question 2 from the 2012 Level 1 Mechanics paper. On athletics day, two friends compete in the same 100 metre race. The speed time graphs for their race are shown below. Oops, I meant to zoom. The black darker line is Sam and the dotted line is Tama. If we script down, first question from the graph, who is the greater acceleration in the first 2 seconds? The first 2 seconds is during this section, and we can see that Sam reaches a higher speed quicker. They both start at 0. Sam reaches higher speed quicker over that 2 seconds. He just reaches a higher speed in 2 seconds than Tama does. So Sam's acceleration is the greater, and it says give a reason for your answer, and we've said that. So we would look at the Sam, and the slope is steeper. That's the easiest way to look at it. The slope of a distance of a speed time graph gives the acceleration. B. Sam accelerates for the first 2 seconds of the race. During this time he covers a distance of 9 meters. His mass is 60 kilograms. Use them in the graph, calculate Sam's acceleration during the first 2 seconds, and then calculate the work done to cover the distance of 9 meters. So we need the acceleration, which is going to be the distance, the 9 meters per second change in speed over the time, which was 2 seconds, which will give him 4.5 meters per second squared acceleration. And then calculate the work done. Let's look at the work done. Remember, is the force times by the distance. The force in this case excuse me, is going to be equal to the mass times the acceleration. We've calculated the acceleration above, and the mass is the 60 kilograms of Sam that we use there. A common misconception for this question would be to skip straight to the work. Work equals force times distance, force being mass times gravity, so you'd have the downwards gravitational force times by the distance, but that would only work if you are raising Sam up vertically. In this case we're horizontal, so we have to look at his horizontal force, which comes from his horizontal speed, horizontal change in speed over time, his horizontal acceleration, that is, times by the mass. Okay, and when you put in what you calculate from that force into there, plus the distance being 9 meters from above, you get a particular answer, which I don't know, but that's how you work it out. C. Part 1. Use the information of the graph to compare the speed and acceleration of Sam and Tama in the first 10 seconds. So, speed and acceleration. So, in the first 10 seconds, we're only interested in this section of the graph up to here. So, both of them accelerate and then level off at a constant speed. So, Sam, if we look at Sam, his acceleration is greater than Tama's. Tama's acceleration is less than Sam's. Sam's top speed is 9 meters per second, which is slower than Tama's top speed at 10 meters per second. So if you're comparing, what this question's asking for is just to describe the curve for Sam and the curve for Tama. They're straight lines, but we talk about a curve as being the plot. And then to compare them, so he's just saying which one is steeper and which one reaches a higher level and so forth. So that's the speed and acceleration, and this question is combined with the question below. Use the information of the graph and any necessary calculations to show is finished at 12 seconds. So the information above combined with this is meant to give you one overall grade. So how do we work out who's finished the race first? I'm going to have to make this a little bit smaller. The solution is to go by the area under the graph, because the area under the graph is equal to the distance covered. So we'd have to do it once for Sam, using this red area, and it's at 12 seconds, so we go all the way to the end. So we'd probably split it into that triangle, that square, so we've got this triangle, this square, this rectangular bit, it's not actually a square, and the smaller triangle, and you'd find that Sam actually has 101 meters thereabouts, so he's finished. If we're looking at Tama, we'd probably use that triangle for one part, so half base times the height for that. Then we would, actually making it a little bit easier, we'd do this square, we could have done that with Sam as well, and then this little triangle, and you would add it up to find that he's about 97 meters. So the faster acceleration gets you to the top speed quicker and gets you over the line faster. So The SAM's finished, and those are the calculations you'll do here under the graph.